C++ provides another way to format output using a special function called the printf function. This function is used primarily with numeric output and is not used all that much in C++, although it was very popular in the C language, which of course is the mother language to C++. Still, it provides some utility in your C++ programs, so I'm going to discuss it here. The first thing we need to do to use the printf function is to pound include a special library called cstdio. The C means that this library comes from the C language, and stdio just stands for standard input-output. Once we've done that, now we're ready to use the printf function. So first, let's create a variable, a double. It'll be pi, and we'll declare pi to a few digits. Now let's use printf. The printf function is called just by using its name, and then open parentheses for the arguments. The first argument is something called a format string. The format string is begun with a %, followed by an indicator of the type of number you want to display, or the type of output you want to display if it's not a number. In this case, we want f for floating point. That's all we want for the format string, so we'll close it out with a close quote, and then let's put the variable or value we want to display. In this case, it's the value that's stored in pi. Close off with the semicolon, and then build and run the program. All right, so we see there's pi displayed to 6 digits of precision, which is less than we defined when we created the variable. That's because that is the default number of digits to be displayed. Let's look at another example. We can specify in the format string the number of places to print, which is kind of like what we did with the setW function earlier. In this case, we'll still work with pi. And here we're telling it we want to have a field of 10, or 10 places. So let's build and run the program. Okay, so you see that it justified the number pi within the field, which is pretty much what setW does. Let's look at another example here. This time let's tell it how many digits after the decimal place we want. So we'll stick with the 10, and let's tell it that we want 6 digits after the decimal place. To do that, we put a 0.6 after the field specifier, or the field length specifier, followed by the f for the floating point, and then the value that we want. Let's build and run. So we still got 6. Let's make it a little more precision, so I'm just going to modify that. Let's set it to 8. Build and run. Okay, there we go. Now we see exactly what we defined pi to be. Inside the format string, you can also do things like add the new line characters. If we want to display a number, then add a new line, we can just add the new line character at the end of the format string. Build and run. And now we have a blank line. The printf function works with other kind of numbers, of course, so let's work a little bit with integers here. So let's create an integer. Let's display the integer. The format specifier for integers is D for decimal number. Type in the value we want. Build and run. And there's our 100. If we want to print that value in a bigger field, of course, we can do that very easily. Let's do 15 just to be different this time. Build and run. Okay, so that's about what we expected. Of course, we can add a new line character. I'll do that in a moment. Another nice thing we can do with this is we can also, let me comment out so we can keep these examples running. We can also put a plus or minus sign in the display of the number. Now, that's typical with most computer languages will display a negative sign when a number is a negative, but most languages, I'd say all languages, do not display the plus sign. But if we want to display the plus sign, we can do that by putting the plus sign at the beginning of the format specifier right after the %. Just like so. And there's the plus. Of course, we don't have to do that with the negative number, since those are specified automatically, let's make number -100. Take out the plus just so we don't confuse everything. Run this program, and -100 appears automatically. Finally, we can display strings with printf. The format specifier for a string is an S. Let's put a new line in there just to have it in there. So we'll do our standard hello world. Oops, have a mistake. We'll just fix that real quick. It's good to see mistakes every once in a while and how easy it is to fix them. And there's hello world. Now, here's a problem with the printf function. Because printf was designed to work with the C language, the C language does not have the built-in data type string that C++ has. So what that means is that if we try to display a string using the printf function, we're going to get an error. Let's try it just so you know what I'm talking about. There's our format specifier. The string name is hello. And if we try to build and run, we see that's an error right there. The error reads, cannot pass objects of non-trivially copyable type struct std : string through ... But in reality, what that's just telling you is that the printf function does not have the capability of handling the data type string. Just as an aside, the C language did have strings, but they were arrays of chars or characters. Later in the course, we might look at some examples of that just for your own illumination. That just about covers everything I want to cover with the cout and outputting data. In my next video, we'll start talking about input into C++ programs.